Hi everyone, welcome back to the coding series. Today's problem is valid anagram. Let's understand the problem statement. Given two strings S and T, return true if T is an anagram of yes and false otherwise. So now let's understand what is meant by valid anagram. Okay, so valid anagram means two strings S and T are made using the same characters in the same frequency, just rearranged. So that is the definition of valid anagram. Okay, now let's understand that with the example. Okay, so in these two strings, if you observe, these two strings are made using the same characters in the same frequency. Okay, so in that case, these two strings are valid anagram. So in that case, you have to return true. In the second example, these two strings are not made with the same characters. So you have to return false. Now let's see how we can solve this. Okay, we'll start with approach 1. Okay, we'll start with approach 1. So given S and T, okay, anagram, and so this is okay. Now we will calculate the frequency of each character in S, and so we'll calculate. Okay, so if you see, we have 3 A's and G1, so R is also 1, M is also 1, and N is also 1. Similarly, we will calculate in T as well. Okay, so we have 3 A characters, and similarly G is also 1, R is also 1, so M is also 1, and N is also 1. Okay, if you see, these two strings are made using the same characters in the same frequency, right? So this is satisfying the valid anagram definition. So these two strings are valid anagram. So you have to return true. Now, so in the approach 1, what we will do is we will take two hash maps. One is hash map 1 and hash map 2. So how we have done here? So we will calculate each character's frequency and store that in the hash map. So when you calculate for each character their frequency, so that will be same G1, okay, 1, M is also 1, and N is also 1. Similarly, you will calculate each character's frequency in T and store that in the hash map. Okay, similarly that also will be like this. Okay, so after that you will iterate over the hash map and check the values of each keys. Okay, so you will iterate over a hash map and calculate if hash map 1 of key equal to hash map 2 of key, then what you have to do? You have to continue checking others characters frequency. Okay, if you check their keys frequencies are not equal, then you have to just return false. So you need no need to check other characters frequency, right? So in that case you will return false. Else if you are successfully coming out of this for loop, then you can just return true. That means these two strings are valid anagram. You can say that. Okay. Now, if you see the time complexity and space complexity, okay, since we are iterating over a for loop, so that will be O of n. And if you're storing in hash map n unique characters, then that will be O of n plus O of n, that will be O of n. So this is quite big. Okay. So we can still reduce this space complexity. Okay. So I will explain that in the approach 2. Okay. So before to that, I will show you the code for this. Okay. For the approach 1. So this will be the first check. If both lengths are not equal, then we can be sure that there won't be a valid anagram. So I created two hash maps, and this is the logic to store the frequency for each character, and you are iterating over the hash map and checking whether their values are equal or not. If it is not, you can return false. If you are successfully coming out of a loop, you can just return true. Okay. Now, yeah, we'll go with the approach 2. In the approach 2, okay, so if you see in the description, S and T consists of lowercase English letters. So how many lowercase alphabets we have? We have 26, right? So what I will do is I will create one array with the length 26. So that will be 0, 0, 0, 0, 0, and so on. This length will be 26. Okay. So now I will iterate uh, over a string. Oh, so that will be I less than ln of s and I plus plus. Okay. So before to this, we have to add the check like if ln of s not equal to ln of t, then you can just return false. False. Okay. Here what I will do is, okay, since we are having 26 alphabets, so I created one array with a length 26. Okay. So let's take s is equals to anagram and t is equals to nagaram. Okay. Now count of, okay, s of I. Okay. When you access each value in a string, okay, that will be byte. So byte is nothing but a ASCII value, right? So what I will do here, count of, I'll explain you, and similarly you will just increment that count, and for this t of y, for the same character or a different, you will decrement. Okay. So now now so what is the, so when I equal to 0, okay, when I equal to 0, ASCII value of a is 9, right? So this is also byte. So when s of I, so we will just s of 0 minus a. Okay, That means 97 minus 97. ASCII value of this and ASCII value of this 97, that is 0. So count of 0th index, you are incrementing. So count of 0th index is 0. You are incrementing means this becomes 1. Okay. Now, so similarly you will check for t. So t of I is n. Okay. Now t of 0 minus a. Okay. So so what is the ASCII character of this one? 110. Okay. So, 110 minus 97. So 110 minus 97 is 13. So count of this is 13. Okay. Count of index 13 is initially it will be 0, right? You will increment that. Sorry, you will decrement. Okay. If you are decrementing, so that will be some initially if it's this is index 13, so it will be minus 1. Okay. Now because 0 minus 1 minus 1. Now when I equal to 1, so here n, right? So that will be count of 13. So count of 13, what you are doing here? Count of 13, you are incrementing. You are incrementing plus plus. So minus 1 plus 1, that is 0, right? Again it becomes 0. So now you have to check a because t of I. So 97 minus 97. So that is count of 0. Count of 0 you are decrementing. Decrementing means this will be 0. So like that you will check for, you will iterate over this entire for loop, and if you're finding, so for each character you subtract with a, and following that you will either increment or decrement. So in that case, so if you see, then okay, so for this we have 3. So for this we have 3, and similarly n is frequency. So this one G also forming 1. Now I'm writing the frequencies. Okay. So 1 1. Okay. Now here also m1 and 1. Okay. So when you, for s of I minus a, I am incrementing the count. Okay. So and count of t minus a, I am decrementing the count. So that means if, okay, in these two strings, if their characters, if they are having the same characters with the same frequency, ultimately their value in this count array will be 0, right? That means because you're incrementing for uh, s of I minus a and decrementing for t of I minus a. Okay. Indexes for the count. Okay. So if these two strings are forming with the same characters and in the same frequency, okay, ultimately our this count will be with, because when you find a when you find a, you are decrementing again, you will add here a, you will add 1 and decrement by 1. Okay. Similarly you will add 1, decrement 1, you will add 1, decrement 1. Ultimately that index value will be 0. Okay. So when two strings are forming valid anagram, means Ultimately, this count array after this for loop will have the values 0 at each index. Okay. Now you have to iterate over you have to iterate over okay count count array if v not equal to 0, then if it is not equal to 0 means some extra characters or their some maybe the extra characters can be present or might be the frequencies cannot be matching. So in that case you can just return false. Okay. So else what you can do, you have to, and in the end you can just return true. I hope this will be clear. So if two strings are if two strings are forming valid anagram means after this for loop, okay, our count array will be having value, our count array will be having value 0 at each index. Okay, like this. Okay, if it is not, then somewhere something like this our count array will be. That means might be these two strings might be having the extra characters, even if they are having the same characters, might be frequency cannot be matching. In that case our count will look something like this. So for that this is the check. So if v is not equal to 0, if the value is not equal to 0, then you have to return false. Okay. Now, so if you see that, let we will just code that. Okay, I will erase this. Okay, so that will be as it is. So for count, make of array of int, comma 26. Okay, now you will iterate for I is equal to 0, I less than ln of s, I plus plus. So count of s of I minus, okay, I will just reverse. For t of I minus a, I will increment because both should work, right? So count of s of I minus a, I will decrement. Sorry. After that, so for values in each in array, if v not equal to 0, you can just return false, or else you can just return true. Let's run. I don't know why it's not working. Okay, so what we will do is equal to 0, I less than ln of count I plus plus. So for this, what we will do, count of I, if count of I not equal to 0, okay, yeah, now let's submit this. Okay, all test cases are passed. So if you think about the time complexity, we are iterating over a for loops that will be O of n. Okay, but the space complexity, since we are storing only 26 characters in an array, that is constant value. So space complexity is O of 1 and time complexity is O of n. So for the approach one, we have space complexity O of n. So we have reduced that to O of 1. So that's all for today's guys. If you have any questions, please do add in the comment section. Like and subscribe for more videos. Thank you.